we want to move on to our speaker for today's Voices of Data Science event. The speaker is Aishwarya Srinivasan. She's working as a data scientist in the Google Cloud AI Services team. She is working on building learning solutions for customer use cases. Previously, she also worked as an AI and an machine learning innovation leader at IBM Data and AI Center. So today, for this talk, Aishwarya's topic is tackling data utility and privacy trade-off with federated learning. So insight derived from this data, these are driving force behind organizational growth. And also this is because the insights derived from the data disclose valuable user behaviors, also social interactions, spending information, and much more. Conversely, this data contains sensitive information, and users have been subsequently subjected to unwanted personal advertising. So data sharing to third parties, other privacy breaches can be very in terms of privacy concerns. So in this talk, Aishwarya's she will discuss how federated learning can be used to help navigate this privacy issue, so that organizations or the company can derive high-value insights within the constraints of respecting privacy. So, yeah. So we want to invite Aishwarya for our stage.
Hello everyone. My name is Aishwarya Srinivasan, and I'm really excited to talk to all of you today, and especially talk about a topic which I'm really excited about. So today I'll be talking about data privacy and what kind of data leads to breach in privacy, and followed by what organizations can do, especially B2C companies who are making products for consumers like you and me, and how can they protect their interests of making the best kind of models while ensuring that we are taking care of privacy. So let me go ahead and share my screen. Let me know if the screen is visible. Okay. So as I mentioned, like today I'll be talking about the data privacy and how we can tackle that particular how we can tackle that particular trade-off, right? It's always a trade-off between data privacy and how good of a model you can build. So I'm as part of the agenda, we have four things that we'll be discussing today. We'll be talking about data privacy and data utility trade-off. Then we'll be briefly looking at what federated learning is, what are the pros and cons of using this technology, and thirdly, we'll talk about a particular use case and end with key takeaways. So let me start with the kind of data that's being collected by B2C companies or like any kind of platforms that we are using, right? So they can be categorized into four categories. One is personal data, the second is engagement data, the third is behavioral data, and the fourth is attitudinal data. So under personal data, we obviously have information about the person, their preferences, their interests, their PII information, and any kind of other sensitive information. The second topic would be the engagement data, where the companies are trying to understand and collect data regarding your engagement with that particular product or platform. On how often do you log in, log off, how much time you're spending on the platform, etc. The third would be behavioral data, where they're trying to understand and analyze your behavior on that platform. For example, which could be what are the products that you're trying to buy on the platform? What are the products which are of your interest, which you're clicking on, etc. And the fourth part is the attitudinal data. So the attitudinal data basically is a sort of a soft line between the behavioral and attitudinal data, where we are trying to understand the reaction of the customers on the products or services that they have utilized on the platform. So this could be reviews, stars, or any kind of ratings that they are leaving on the platform for the products and services they have utilized on the platform. So broadly speaking, these are the data that's being collected by the users for like analytics purposes by the companies, right? Now, what does the company use this data for? One is obviously improving your customer experience. They want more engagement from the customers. They want more people accessing their website for services and products. So they want to improve the customer experience. So they are trying to analyze the pattern and the behavioral data from the customers, and they're trying to improve the customer experience. The second one is, of course, like refining the marketing strategies, where they are saying that what are the products which are highly in demand by the customers? How do we put offers on certain kinds of products so that they're selling more, etc. And the third one is basically converting data into cash flow. So this is also like different ways of how companies function. One is, of course, using this data for ads and services. So websites are using these for sponsored posts, etc. So they are basically converting your data, the data that they've collected from you, into a cash flow mechanism. And the fourth being, of course, collecting more data. So with more engagement, with better customer experience, with better marketing strategies, there are going to be more users coming onto the platform, and that means they are going to collect more data. More data is going to help them build their business as you would know it. Now let's talk about like what data privacy is, right? So data privacy defines how a particular piece of information or data should or should not be handled by the authorized access, and based on the level of importance the person who's trying to access has. With the introduction to AI, like with having like machine learning and deep learning models, a lot of personal information can be extracted from these models. So using the data, there can be a lot of information that can be extracted, and that can also cause a lot of damage in a way. So we had recently seen I would not say recently, but some time ago, we had seen a use case where an e-commerce company started giving out pregnancy product recommendation to a particular user based on their maybe like internet search or other activities on the internet, and that sort of caused a huge problem because that user did not want to release out the information that they were pregnant or not, and that sort of like crossed the line of the data privacy that the user wanted to maintain. And these are the kind of situations that we are talking about, where um, it's important to maintain data privacy. It's important that we have it in our hands on what we want to share and what we don't. And any kind of data that's being received, like that's being tracked from me, is not used for targeted marketing. So that's something which I should have the option to control, right? And that's upon the individual to make sure that that doesn't happen. And in such kind of scenarios, we have seen a lot of governance policy coming up. So European Union made the first step into this. They started with the GDPR, which sort of lays out specific rules about how data can be collected, stored, deleted based on the preference of the users, and about the transparency aspect as well. So we see more and more organizations or governmental bodies pushing towards this particular initiative, where they are creating awareness about data privacy. They're creating awareness about how data should be used, and this is probably a new era where we are seeing more and more companies, especially using data as their primary asset. So every business model is somewhere spinning around what data do they have, what how can they leverage the data to build a better business model. So in that case, we do not currently have good governmental rules and policies in place that takes into care how data should be and should not be used by organizations, and especially with machine learning models being built, how that impacts the users or how that impacts the community in general. So let's go to the next point where I talk about data utility versus data privacy, right? Data utility is a very simple concept that garbage in, garbage out, right? The better data you have, the more data you have, there are more chances that you are able to predict something or recommend something to a user. So consider a situation where a hypothetical situation where, let's say, your audio data is being collected every single day while you are at home, and based on what you talk with your partner at home or your family at home, um, there are, like, recommendations or suggestions that you're getting for a particular vacation, or rental cars, or any kind of products that you might be interested in. On one phase of things, you might feel that, hey, this is awesome, because now I don't have to spend so much time browsing through something, or I don't have to look for itinerary, or I don't have to go look for specific hotels and reservations, because somewhere that background research is being taken care of by the AI algorithms which are analyzing my voice. But at the same time, there is a line that is being crossed about your data being accessed at all times, and what could be the possible ill effects of that. So there could be a lot of conversation people might be having at their homes about confidential things, about sensitive information, which they might not want that any company or any third party have access to. So that's the trade-off that we're talking about. So if companies have more data about you, more data about your daily changing interests, they have more data about the activities that you're doing at every second during the day, they are of course going to give you better recommendation. But at that point, you need to realize that what's the point, what's the line that I want to cross with respect to sharing my data. So this is one of the places where the concept of federated learning, or like the technology, came up, and it's a fairly new technology in implementation. So this is basically a form of collaborative learning where we are trying to say that users do not really share their data. So there's no data that's being transmitted by the user devices, or any interaction that you're having with the application, but rather it's sort of a cumulative insight that's being sent to the organization. So your individual personal data or your individual behavioral engagement, any of that data is not being sent in a raw form to the company. Instead, what's happening is machine learning model training is being decentralized into each and every device of ours. So at this point, what's happening is the company is going to enable a mechanism where they are sending a model with a seed weight into each of the devices of the users, and based on the engagement, based on the behavioral data that they are seeing on the particular device, the model is going to be trained on the device itself. So the data is not being transmitted from the device to the company or any organization in this case. And once the model is trained, the model with the updated weights is sent back to the organization, and that is what is being aggregated. So at this point, there is no data sharing happening whatsoever. So what the aim of the company or the organization is to build a model that takes into consideration all kinds of people, all kinds of preferences, etc., and that itself is having just by sending the model training back to the customer devices. So one of the common questions that I have had is around re-engineering, right? Like, let's say that we have a model trained, we are sending the trained model back to the organization. Can my data be extracted back from that particular model training? Absolutely not. So the technology is designed is that the red devices or whatever you see on the left picture on the screen are the devices from where the model is being trained, and all the individual models that are trained are going to be encrypted. So the only point at which the models are decrypted are once they are aggregated. So think about it in a way that encrypted models are flying in from each and every device, and that's being aggregated. And only after aggregation can we decrypt the final model. So that sort of gives a secure aggregation mechanism and makes sure that any kind of re-engineering to extract data does not happen in this scenario. So now the other point is, oftentimes when we are training models, we realize that model tend to capture some very specific data. So there are times when, we see that if there is a very anomaly kind of data point, or like something which is not fitting into the similar distribution to the rest of the data points, it tends to be shown out in a particular model. So what does happen in this scenario? So that's where we are bringing in the concept of differential privacy. So what happens in differential privacy is when we are trying to train each and every model independently, there is a lot of noise that is being added to that data point before training. So that no peculiarity in the data point is captured by the model. So this way we are sort of doing an adversarial model training as well as accounting for the differential privacy. So any particular peculiar data point will not be captured by the model in an anomalous way. So these are the two different kinds of differential privacy that we use. So one is local differential privacy, and the other one is global differential privacy. So local differential privacy oftentimes occur in the device itself. So every data point is being fed with extra noise, and then the model is trained on top of it so that it does not capture specific information. The other part is doing a global differential privacy, where you're adding that noise on the global data set itself, or like in the global manner, and not in each and every independent data point. So, following up on that, we need to understand how do we test our models. So, in ideal situations, the way we train and test our model is that we have the ability to capture the train and test and validation set. We train the model using the train set, validate it for like further tuning, and then finally test it on the test set. But in this case, we don't really have that. We don't have the test data with ourselves. So how do we test these models, right? So even similar to how we trained the model, we're going to be testing the models on the device end itself. So once we collect, say, 100,000 user data, which is the trained model weights which we are aggregating, once we do that, we are going to be sending back the models back to the devices and testing that particular, could be a recommendation system, could be a particular feature enhancement, etc., on these devices. And based on the feedback that we get, or like the accuracy measure or whatever metric we're trying to measure in those cases, we take that feedback and then retrain the model based on the updated model weights that we receive from the devices. So that's the process of retraining or like uptraining the model that we have on each of the devices. So, covering everything up, like once we have discussed everything about federated learning and how it can be used in different kind of scenarios, I felt it's important to also like point out a case study which is more of a B2B, if you may say, because in this case there are no users, like no independent or individual users who are being part of the federated learning framework. It is more of organizations or business entities, right? So we are looking at a use case where we have different financial institutes, and they want to build a better model for anti-money laundering, right? So different smaller financial institutes have a lot of data which they store independently. Of course, like there's a lot of sensitive information and personally identifiable information which they cannot share with each other. So the data set that each and every organization has is probably a small subset of the global anti money laundering data that we have, right? So in this case, we can design a federated learning framework where, as you see in the picture, like you have Bank A, Bank B, Bank C, and Bank D, and you can have more financial institutes as well who are collaborating together for training a central anti-money laundering system. So what's happening in this case is we have a central arbiter where we are from where we are sending out a empty model with a basic seed weights, and each and every bank is going to train that empty model, or like untrained model, what you as you may call it, using their data set. And once they have trained the model, they are going to send the updated model weights back to the central arbiter. Similarly, all the banks do that. And at the central arbiter level, now we are going to aggregate all the models which have been received by the different business entities. Once we have that, we are having a global knowledge, or like the global insight into all different variety of money laundering cases, and that helps us build a better system to avoid such kind of scenarios. So this is again like a one specific case study for financial institutes. There are many other case studies which focus on healthcare, on like how different healthcare organization can work together in building a better cancer detection based on images. And they are not really sharing data with each other, but they are sharing the knowledge or the insights that they've gathered based on that data using trained model weights. So Right. So let me summarize it as part of the key takeaways, where we talk about better personalization is achieved by building a better model, which needs better data, right? So it's a connected loop that we see that only if you have better data, only if you have enough data, you can build a very personalized model. And similarly, what we are trying to do with federated learning is that we are not trying to kill the concept of having more data. Rather, we are trying to kill the concept of sharing that data. So we are trying to centralize the model building while the data is still on decentralized devices or decentralized systems. So as I mentioned, the data is not going to be going to any central server. There is no central collection of data. So there's no single party who is going to have access to all of your data. So the data stays in your hand, and while the organization is able to extract the insights out of that data and build the personalized model or any other model that we're looking at for to serve their purpose. So that being said, I'm happy to like answer any questions right now, or if anybody's watching a recorded session of this later on, like feel free to reach out to me on LinkedIn. I'll be happy to answer any of your questions, and let me know if there are any questions from the audience right now.
Yeah. Thank you so much, Aishwarya. That was really insightful talk. We your time for introducing and explaining how learning can respect both privacy and be providing corporations insights into their products. Yeah, we really appreciate your explanation. Thank you. So I see there are a couple questions from the audience. So the first question is, which companies or which organizations currently integrating federated learning into their business models, and those that approach prove to be in the management?
So far, as much as I know, the only like there are very few companies who are actively researching on the concept, and TensorFlow is one of the framework that can be used for building federated learning systems. So based on my research, like Google has started implementing it at some scale. And they have white papers available online which talk about how they are integrating this for like improving their maps, how they are using it for improving keyboard recommendations, etc. So that's something which is available online, and I'm happy to share any kind of resources which is required. So far, apart from Google or like a few other companies, it's not been scaled a lot, and I'll give you a reason for that. So the use case that I was talking about, right, where different financial organizations can collaborate to build a better anti-money laundering system, or like to build a better credit scoring system. In theory, yes, that can happen, but in practice, there are a lot of legal concerns, or a lot of, I would say, company related issues that arise where the companies are not comfortable in using the technology, and it's very difficult to bring, say, 10 different financial institutions onto the same board and make them sign something where they are agreeing to, like train a central model through this distributed scenario. So what is mostly happening right now is a single organization is because now all the legal concerns are just within the particular organization. So that is more of a feasible solution, and a lot of organizations are trying that. But when it comes to like distributed organizations, or like even different business units being involved in that, that takes a lot of effort with respect to like legal perspective, and that's where we see a pushback, because we're using a new technology, not a proven scalable technology so far. So there's still a lot of groundwork that's happening, and yeah, that's where I see the current scenario is.
Yeah, thank you so much. And we have other questions. So here's the question. So are these federated learning processes being used at Google this time?
Yeah, based on some of the again, like white papers and blogs that have been published, they are being used at some capacity. So yeah, of course, like I cannot speak to everything that the federated learning team is doing at Google, but I can definitely share whatever resources is available on the internet, which people can go through.
Yeah. Yeah. There's another question. So how is federated learning more advantageous than data anonymization? Because federated doesn't provide access to actual data. Could you
Right.
about this?
Sure. So data anonymization again is giving the responsibility to some people or some technology to anonymize the data, right? And we have had multiple scenarios where even after data anonymization, there has been reverse engineering. There are proxy attributes which are used to unanonymize the anonymized data. So that's not a proven mechanism is what we have seen so far. It's still being used because we don't have any alternate mechanism. PII is still somewhere being part of a majority of the data sets that organizations are being used. It's claimed that they are either being like redacted or obfuscated based on like different like data privacy policies they're following. But the question is, again, users are giving that trust on the company, right? Like you're giving that trust on the data scientist or the data science team in that company, that they will anonymize the data or they are going to follow that particular privacy policies. So at some point we need to take that responsibility on ourselves, that we have more transparency into the process, and that's where I believe federated learning is a better approach than leaving that responsibility on an organization and then just trusting them on that.
Right. Question is, how can a person ensure fairness while doing federated learning?
Fairness.
Yes.
That's an interesting question. So, one of the things that's currently happening, each and every model training that's being done on individual devices are being aggregated to some level, and at that point, as I mentioned, like there's a differential privacy that's applied, so that introduces noise to remove any kind of peculiarities in individual data sets, right? So at the global level, once the model is integrated, we are trying to make sure that there are no glaring differences, or like there are no I would say like bias sets that we see in the data prediction. So that's something that's ensured. And at the data collection level, I would say not collection level, at the level where we are training the models individually on the devices, we make sure that we are only collecting data that does not contribute to any kind of existing biases. So like any kind of information regarding like race, gender, any of those information are not being used to train the models at the first place.
Yeah, it's really quite insightful question, and thank you so much. So yeah, so thank you so much, Aishwarya, for your answers about these questions, and we are so grateful to have you as a speaker for this technical talk. So yeah, we really appreciate it. And also, she be at the network sessions in an hours. So yeah, everyone can have a short talk with Aishwarya and get some answers about your question Even her project about the federated learning, and even for her experience and her work experience at Google. So yeah, thank you so much, Aishwarya. Yeah,
Thank you, Minwa.
thank you. So yeah, here we are at the end of technical talks for the voices of data science. I feel really so stimulated by all talks that we had today. So much for everyone for here, for being so interactive, and for such a great audience. Thank you so much. So yeah. So now we will have a quiz session. So to see if you're paying attention, we have a really a small trivia segment for you. So the best part is we have prizes. So the first and second place winners will get $100 and $50 Amazon gift cards respectively. So yeah, so put on your thinking caps and join us for a trivia time with Zai.